My name is Michael Sheetz. I work at the Mechanobiology Institute at the National University of Singapore and hold a secondary appointment at Columbia University in New York City, US. We are interested in understanding how cells interact with their environment. One of the important aspects of the cell mechanics is that a cell, when it's a stem cell, will measure that rigidity and differentiate into a brain if it's soft or into a bone-like cell if it's rigid. And we have described a molecular complex which is like a muscle sarcomere in that it pinches, pulls, and it will pull on the matrix, thereby pinching that matrix to determine the rigidity. That important parameter then determines whether the cell will live, or if it's on a soft surface, if that cell will die. Now, most recently, we've taken this into the area of cancer biology, where the majority of cells will live on soft surfaces. And what we find is that those cells from the cancer patients lack the ability to sense rigidity. And they do lack that ability because of a number of cytoskeletal proteins that are involved in making this machine that pulls on the matrix and thereby senses rigidity. So that realistically, what we can do with those cancer cells is add back a single cytoskeletal protein, and now they die on soft surfaces. They're no longer metastatic, and this gives us a clue about what is a major defect in the cancer cells. We are looking into that from the point of view of can we, now knowing this, use inhibitors of cytoskeletal protein function to block the transformed cells in terms of their growth. And there are some promising candidates along that line. The best aspect of being a scientist, and I'm beyond the retirement age of most, is that indeed you have a number of challenges every day. And you get to answer questions that have, interested you, and you have the freedom to follow up on that. And that's really been a lot of fun to pose those questions, set up a hypothesis, and then be able to go and test it.